Hello, nearest fellow and all over the world. I welcome you all in this course on Engineering Drawing 1. Today we will discuss engineering drawing definitions and principles and which textbook we are using in this video. The book is this Manual of Engineering Drawing to British and International Standard. That is the second edition book. You can find the latest book on internet. Is available. I'm sorry. Okay, what is included in this video? What is the content? The definition of engineering drawing, principle of first and third angle orthographic projection, projection symbol, drawing paper size, the layout of drawing sheet, how to begin your drawing, keeping the drawing clean is a must. Okay, what is the definitions of engineering drawing? An engineering drawing, a type of technical drawing, is used to fully and clearly define requirements for engineered items. Engineering drawing produce engineering drawings more than merely the drawing of pictures. It is also a language, a graphical language that communicates item and information from one mind to another mind. Most especially, it communicates all needed information from the engineer who design a part to the workers who will make it. Okay, principle of first and third angle orthographic projection. Now we will discuss the first angle projection, then we will start the third angle projection. In first angle projection, you can see there is a figure 1. We have graph, and let me explain you in step by step. Assume that a small box is made 35 millimeter height and 30 millimeter length and 20 millimeter width, and that two of the corner are cut away as shown below in the three stages in figure 1. You can see it. And in figure 2, illustrate a pictorial view of the block, and this has been arranged in an arbitrary way because none of the faces are more important than the others. In order to describe the orthographic view, we need to select a principal view, and in this case we have chosen the view in the direction of arrow A here, that to be the view from the front. We are considering this A direction, A arrow, that is the front view. The B is the left view, and the C is the right view, and the D is the top view, and the E is in the beneath view, which we are going to discuss in the coming slide. The 5 arrows point to different surface of the block and 5 views will result. The arrows themselves are positioned secured to the surface, that is at 90° to the surface, and they are also at 90° or multiples of 90° to each other. The views are designed as follow. View in direction A is the view in the form the front view, that is the front view. Okay, view in direction B in the view from the left view. As I told before, I started this designed fellow, that is the left view. View in direction C in the view from the right side, that is the C right side. View in direction D in the view form from above, that is the view above side, upper side of the object. View in direction E is the view from the below, that is the beneath view. E views, E direction is the below of the object. According to our references is A is our front view. Okay, in first angle projection, the view in the direction of arrow B, C, D and E are arranged with reference to the front view as follow. The view from B is placed on the right side. Okay, this view, B view is placed, we are drawing this view, that is the B view we are placing on the right side to the this C side, and the view of the C side we are placing to the left side, and the D view we are placing with that upper placed, this place D we are placing in the under beneath in below. The view from E is placed above. This is the below E direction. E views we are placing on the D side. Let's move on. Okay, here is the projection symbol. The first angle projection arrangement, this one, according to previous object, and the dotted line indicate hidden edge and corner. This is the projection symbol for the first angle. That is the projection symbol for the third angle according to our in second picture object. Okay, the experienced daft man will commit the above rules to memory. It is customary to state the projection used on orthographic drawing. To remove all the doubts or use the distinguishing symbols which is shown in the arrangement in figure 3. You can see it. Okay, now we will discuss the third angle projection. The difference between first and third angle projection is in the arrangement of view, and with reference to the illustration in figure 4 according to previous slide, view are now positioned as follow. View B from the left is placed on the left. View C from the right is placed on the right, and the view D from above is placed above. View E above from placed in under beneath. In first angle projection, if is it the left side, you placed on right side. If is it the right side view, you placed in left side, and the top view we placed in bottom. The bottom view we placed in top view. In the third angle projection, for example, left view we placed in the left side, and the top view we placed in top view, the bottom view we placed in bottom view, right view we placed in right view. That is the third angle projection. Please don't mix to each other. Okay, study the arrangement shown in figure 4 in the previous slide and remember above rules, because it is vital that the principle of first and third angle projection are understood. The distinguishing symbol for this method is also shown in figure 5. You can see it, figure 5. Figure 5, and the A part shown the positioning of the first angle, and the B part the third angle projection. Traditionally, front view are also known as front elevation. The side view are often known as side or end elevation, and the views from above or beneath are referred to as plane. All of these terms are freely used in industrial drawing offices. Okay, here we will discuss the projection symbol. First angle projection is widely used throughout all parts of Europe and often called European projection. Third angle in this system used in North America and alternatively described as American projection. In the British Isles, where industry work in cooperation with the rest of the world, both systems of projection are regularly in uses. The current British and ISO standards state that both systems of projection are equally acceptable, but they should never be mixed on the same drawing. The projection symbol must be added on the completed drawing to indicate which system has been used. Okay, you can see it in figure 8. The first angle projection symbol is this one, and the third angle projection symbol is this one. You can see it what is the ratio to make it this drawing. I will describe it in coming lines. Figure 8 show the recommended proportion of the two projection symbol, and figure 8 indicate how the first angle symbol was obtained from the projection of a trapped ruler. And figure 10, the third angle alternative is given in figure 10. You can see it as well. Okay, the one more thing what I want to notice here, please note that the movement suggested by the arrow in figure 9, 10 and also in figure 8. Since operation orientation in the main clue to understanding the fundamental difference in projection system. Okay, what is the drawing paper size in engineering drawing 1? The British standard BS 888 Tetra 8 recommended that for normal practical purpose, that area of the largest sheet is 1 square meter and the side are in the ratio of 1:2. You can see it in table 1. But in this engineering drawing 1, we are using A4 size paper to understand and follow the but one more thing, it's depend upon the industries which kind of they are using. They can using A4, A3, which one they want to use, the size of the paper, it's depend on the requirement. Okay, let's move on. The dimensions of the sheet are 841 millimeter into 1189 millimeter. Okay, that is the A0 size of the paper. That area is 1 meter square. For similar sheet, for the smaller sheet, the longer side is progressively held given the designation and the dimensions in table 1. Since the A0 size has the area of 1 square meter, paper weight are conveniently expressed in the unit gram per square meter. You can see it in figure 11, the standard size reduction from 0 to 35 millimeter microfilm. Let me explain. Drawing sheet may be obtained from a standard roll of paper or already cut in size. Cut sheets sometimes have a border of at least 15 millimeter, which to provide a frame, and this frame may be printed with microfilm registration mark, which are triangular in shape and positioned on the border at the vertical and horizontal center line of the sheet. The title blocks are also generally printed in the bottom right hand corner of cut sheet and they contain item of basic information required by the drawing office or use of the drawing. Typically references are as follow: name of the firm, drawing number, component name, drawing scale and the unit of measurement, projection used, which type of projection you used, first angle or third angle, are the symbols you have to draw it when you finish your drawing. Draftman names and the checker signature, date of drawing and subcontinent and modification, cross references with associate drawing or assemblies. Other information will vary according to the branch and the type of industry concerned, but is often standardized by a particular firm for their own specific purpose and convenience. Layout of a drawing sheet. Layout of a drawing sheet, that is the first one borderline, that is the trimmed edge. I means you can remove it, these lines, when you finish it, when you made your drawing. Okay, that is the border and that is the trimmed edge line, 20 millimeter for A4 size paper. That is the reference grade. This one is the title block which I discussed in the previous slides. What there is include title block, the drawing names and the title, what is include, yes, the materials, which kind of used, which symbols they are using, you have to write in title block. Okay, this lines, thick lines should be 20 millimeter, that is the frame. Yes, filling frame, that is the filling frame. Okay, layout of a, we are continuing the previous layout of a engineering sheet. Borders, a minimum of 10 millimeters space left around in between the termed edge of the sheet. Filling margin, minimum 20 millimeters space left on the left hand side with other border included. This provided for taking perforation. Grid reference system. Number of division of a particular sheet depends on complexity of the drawing. The grid along the horizontal edge are labeled in numerals, whereas grid along vertical edge are labels using capital letters. The length of each grid can be between 25 to 75 millimeter. Okay, what is included in the title box? This is located at the bottom right hand corner of every sheet and provided the technical and administrative detail of the drawing. The title box is divided into two zones. Identification zone. In this zone, the details like the identification numbers or parts number and title of the drawing, legal owner of the drawing, etc. are to be mentioned in title box. Additional information zone. Here, identificative items, lime symbol indicating the system of projection, scale used, etc. The technical items, lime method of skew, texture, tolerance, etc. And other administrative items are to be mentioned. Layout of a drawing sheet. In the previous slide, I showed you what you have to write in the title box. In the title box, you should write the scale, 1.1 scale and the 1.2 scale, that is the projection symbol. you have to, that is the title, and that is the name of the institution, name of the institute, name of the student. Okay, here is the name of the company, drawing number, letter denoting session plan, that is the minimum size, title of the drawing, subtitle and heading is written in this series. Okay, layout of a drawing sheet. How to begin your drawing? To start with the preparation of a drawing, the procedure mentioned below may be followed. Clean the drawing board and all the drawing instrument using duster. Fix the drawing sheet on the drawing board. Fix the minimum draft in a convenient position. Draft borderline using HP pencil, lead pencil, HP lead pencil. Complete the title box using HB pencil. Plan spacing of drawing between two problems view beforehand. Printed the problem number on the left top and then comes in the drawing works. Okay, now what is the keeping drawing clean is a must. Keeping the drawing clean is a must. Please never sharpen pencil over the drawing. Number 1. Clean pencil point with a soft cloth after sharpening. Keep drawing instrument clean. Rest hand on drawing instrument as much as possible to avoid smearing the graphite on the drawing. When darkening lines, try to work from the top of the drawing to the bottom and from left to the right across the drawing. Use brush to remove razor particles. Never use hand. Always use appropriate drawing pencil. Okay, thank you. That's all for today. For this course, Engineering Drawing 1, we discussed in Engineering Drawing 1, Engineering Drawing, Principle, Definitions, Projection, Layout of paper, Size of the paper, and etc. And the previous lectures video, you can find it, the links is here. Number 1 is the first lecture, the number 2 is the second lecture. And also you can watch this lecture video from this description. I will mention it here. You can find it on the Zoom account in nearest for the nearest fellow. For the international fellows, you can find it on YouTube in the description file. I will upload it. That file will attach the what we call it, draft file. Thank you so much. That is all for today.